Welcome to the Knowledge Point IT viewers. Today we are going to learn the basic concept that is logical gates. When we move to our today's topic, we are going to learn the four theories. What is OR gate, AND gate, NOT gate, and the truth table. Those are the contents we are going to cover today. First of all, we need to know about the definition of logic gates. Actually, when we are using the computer circuit system, we need the digital circuit because all of the data transmissions are going through the digital circuit. So, as I mentioned in the previous videos, the computer system majorly works based on the input, process and output. The user inputting the data, then the system analyzes the output according to the data. So those functional actions happen using the electrons because that's a transmission through the electron. So electron, which electrons create the logical relationship between the input and output. So we need to concern about that logical relationship into three main types. They are AND gate, OR gate and NOT gate. Those are the main logical gates. Let we learn by one. First of all, we need to study about the OR gate. This is the simple. We need to indicate the OR gate. The definition of the OR gate is if we are going to take the two input as A or B, we need to use the following concept. If we are getting the input 0, 0, we are getting the 0. 1, 0, getting 1. 0, 1, getting 1. 1, 1, we are getting 1. Which means we are gather those data underneath of the truth table. Because we are taking the two inputs, so we can randomly put the input as 0, 0 and we can take 0, 1, 1, 0, 1, 1 because only the computer knows the binary language. The binary which means 0 and 1. The computer cannot understand the normal English language or Sinhala language or Tamil language. So we need to communicate with the computer through the binary language. So I need to put those values in the input. After using the OR gate, we can get those as the output. So I'm going to take 0, 0. Under the AB, we are getting 0. 0, 1, we are getting 1. 1, 0, 1. Because which means if we are getting the output as the Y, which means we are inputting the two inputs A plus B. That's why we are getting this table. Now you can well understand about how the OR gate functioning. Let me move to another gate, which is AND gate. Let me see the definition. Before we move to the definition, this is the simple we use to indicate the AND gate. Here, I'm taking two random inputs. Actually, I'm taking 0, 0. Getting 0. 0, 1, getting 0. 1, 1, only we are getting 1. 1, 0 also, we are getting 0. Which means, can you please assume you are getting the output as Y. which means we are multiplying the two inputs A into B. Actually here we are not used the multiplication simple asterisk, we are using only the full stop to indicate the multiplication. This is the truth table for the AND gate. I am taking the 0, 0, we are getting 0. 0, 1, we are getting 0 because we are multiplying 0 into 1, we will get 0. 1 into 0 also we will get 0. Only we can get 1 for each input should be 1. Because 1 into 1 we will get 1. So which is like the multiplication of two inputs. So you will well understand about the two concept of AND gate and OR gate. Let me go to this another gate, that is NOT gate. Actually the NOT gate, which means it is the negative. When we are inputting the input, we are getting the results as a opposite way. So the only thing is, when you are using the NOT gate, we need to pass the one input. In the previous gates, AND gate and the OR gate, we can pass many or multiple inputs, but through the NOT gate we should pass the one input. So we are passing 0, we are getting the 1. We are passing 1s, we are getting 0. This is the symbol that used to indicate the NOT gate. Actually, can you please assume that you are getting the output as Y. I am passing A because we are getting the output as the negative, which means I am getting A bar or A dash. So which means when we are going to pass the input as 1, we will get 0. When you are going to decide to pass the 0, you will get 1. You will get the negative of the input. So that this is the truth table for the NOT gate. Now I hope you can learn and know about NOT gate, OR gate and AND gate. In the upcoming videos, we will learn more than logic gates. Thanks for viewing. Thanks for subscribing, and please be available in YouTube channel and please engage with us. Thank you.